All right, good afternoon. Hope you all are having a great day. So I sent over my rosters to Ivy Tech yesterday, only to hear back today, this morning, that they're not wanting us to do it the way we've been doing it. They do want us to use dual enroll. So I think Zane, you've already registered for my class on dual enroll. If you haven't, I'm gonna need you to go to this web address here at the top. So ivtech.dualenroll.com. And that's gonna take you to the dual enroll site where you can sign in using your username and password. If you don't have one, you'll have to go to new students and create my account in order to do that. So I'll give you guys, let's go with 8 minutes to see if you can get that done. I'll get a notification once you've got that done. I know there were a couple people in the class having trouble with dual enroll. We've got now until Saturday night, I believe, to get this finished. So we did get a few days extension for those of you who are still working on that knowledge assessment. You've got to get your score up to a 70 by then, as well as enroll for the class using dual enroll. has been about 8 minutes. We're gonna go ahead and get started with today's lesson. Again, if you need help with dual enroll, shoot me an email, a text message. Let me know what the issue is and I'll do my best to help you get it resolved. So today we're going to look at quadratic word problems. So here's an example of a quadratic word problem. We have a ball being thrown into the air. The path of the ball is represented by this equation, h equals negative 16t squared plus 96t plus 200. So that is the path of the ball. And then we're told h is the height, t is the time. And then for part A here, for our problem, so part A right here, we're being asked what is the height of the ball after 1 second. In order to find the height, we need to take these t's, the t's that represent time, in seconds in this case, and we're going to take those out and replace them with the time that we know. So our equation here is going to be h equals negative 16 times the time we know, which is 1. Since we're plugging in that 1, we're going to go ahead and put it in parentheses, square it, plus 96. Again, there's another t, so I'm going to plug in a 1 in parentheses, plus 200. Now that we have this all written down, we just need to simplify this information right here. So we're going to take 1 squared times negative 16 plus 96 times 1 plus 200. If you have a scientific calculator, you can type all of this into your calculator all at once, as long as you use your parentheses. When you get an answer, if you want to drop it in the chat, we'll see what you get. Laura, check to see if you have your negative in front of your 16. Should get 280. So that's going to equal 280. Remember, we found the height. Sometimes you'll see people put height. Other people will just assume that it's feet, since we're talking about a ball. So we know that the height is going to be 280 units. Since they didn't tell us what unit it is, we're just going to put the height. So that's it for part A. We found the height of the ball after 1 second. It's just what I like to say, a plug and chug. You're going to plug in the numbers and chug it into your calculator to figure out the answer. For part B, what is the maximum height reached by the ball And then I've given you a hint, this is a two-step problem. You first have to find the time that it takes to get to the maximum height using negative b divided by 2a, and then do another plug and chug. So if we think about this concept on our graph, I'm going to say that this point right here is the max height. The time that it takes to get there is going to be x. Once we find that x, we can plug it back in to find the y value, or the height in this case. So for the x, we do the negative b divided by 2a, plug that back in. To find that max height. So in this case, first thing we need to do is take negative b divided by 2a. So back to my original problem up here. I have an a value of negative 16, a b value of 96. We don't really need c, but our c value in this case would be 200. So we're going to take negative b, which means we're going to take the opposite of 96. So negative 96 divided by 2 times a, which is negative 16. Then we're going to simplify that. So we're going to take negative 96 divided by negative 32, and that's going to give you positive 3. I'm going to assume since the ball's being thrown that that's going to be seconds. Now that we have the time that it takes for the ball to get to the maximum height, we're going to go ahead and do again another plug and chug. We're going to take that value of 3 and do exactly what we did on the step above. So we're going to find the height using 3 seconds as our time now. And then again, if we're using our calculators correctly, we can go ahead and just type this whole thing in there, making sure we're using those parentheses again. So I'll give you a minute to try to type that in your calculator. Zane has the correct answer in the chat if you want to check it when you get finished. So in this case, h, our height, is going to equal 344. Questions on this one? I'm gonna jump over to the next page, C wouldn't fit, so I went in and just put it on the next slide. So part C, we're still looking at the same equation, but for part C, it asks how long will it take for the ball to be at 88 feet? And then I'm giving you a hint. You're going to set the equation equal to 88. So I'm telling you the height of 88 feet, which is why we're going to plug it in for H. Then we're going to move everything to one side. We're going to factor out a negative 16, and then you're going to solve using an asterisk, or you're going to factor it. And then remember, any negative answer is going to be extraneous because we're talking about time, and time cannot be negative. So step one, we're going to set the equation equal to 88. So we're going to have 88 equals negative 16t squared plus 96t plus 200. The second hint I told you was to move everything to one side. The easiest way to do this is just to move that 88 by subtracting 88 from both sides. So make sure you're subtracting it from like terms. The second thing we want to do, or the next thing we want to do, is factor out a negative 16. The reason we want to factor out a negative 16, we want to factor out whatever is sitting here, if at all possible. It's going to make your lives easier. It's just the greatest common factor for the right-hand side. So we're going to factor out a negative 16. If I take negative 16t squared and I factor out negative 16, that leaves me with 1t squared. Plus 96t, if I take 96 and I divide it by negative 16, I'm going to get negative 6t. Positive 112 divided by negative 16 is going to be negative 7. So now we want to take the quadratic that we now have in parentheses, and we want to factor it. So I know we talked about it the last couple of days. When I factor using Kimmel's asterisk method, where we start with the leading coefficient, A in the top left, top right, B in the bottom middle, so negative 6 in the bottom middle. And then for the top middle, we're going to go ahead and multiply A times C. 1 times negative 7 is negative 7. And now we need to find two numbers to fill in those two holes. The two numbers have to multiply to give you the top and add to give you the bottom. For some reason, I can't. So those two numbers are going to be negative 7 and positive 1. So now I'm going to look at the two sides to see if I can simplify. In this case, I haven't. So now I have 0 equals negative 16 because we haven't done anything with that. And then our two factors, 1t minus 7 or t minus 7, and then t plus 1 or 1t plus 1. So now that we have our factors, we're going to go ahead and use that zero product property to set all the terms equal to 0. So the first term here, negative 16 equals 0. That's never going to happen. There's no variable there, so there's no answer with that portion. T minus 7 equals 0 and t plus 1 equals 0. So in this case, I'm getting t equals 7 and t equals negative 1. And then remember, we're talking about time. Time is always represented as a positive number. So in this case, the t equals negative 1 is extraneous. So it doesn't mean you did anything wrong in the problem. It just means that the negative 1 doesn't make sense for this problem. So it doesn't make sense if you tell me the time was negative 1. It would make sense if you told me the time was 7. Again, probably 7 seconds if you wanted to go ahead and label it as 7 seconds because we're throwing a ball. We know it's not going to be 7 minutes. All right, questions on this one? All right. Going down to the next one, here we have a diver jumping off a diving board. The path of the diver is represented by h equals negative 16t squared plus 16t plus 192. For part A, we want to know what is the height of the diver after 2 seconds. That is, again, a plug and chug. So we're being asked to find h, which means we just need to go into the equation, replace t with 2 seconds. So negative 16 times 2 squared plus 16 times 2 plus 192. So in this case, when you type all of this into your calculator, you should be getting an answer of 160. We're going to go ahead and label it feet. We've got a diver jumping off a diving board, 160 feet. Part B wants to know how long does it take the diver to reach the maximum height? So we're being asked to find the time that it takes to get to this point. Remember, that's our negative b divided by 2a. So for part B, we're going to do negative b divided by 2a. So in this case, we're gonna get -16 divided by -32. I'm gonna go ahead and simplify that to 1/2 or 0.5 and label it seconds. So we've got this diver who jumps off the diving board. In half a second, that diver has reached its maximum height. Now that we know the time it takes the diver to get to the maximum height, we can go ahead and compute the maximum height of that diver by plugging in for the time into the original equation. So to find the height, or maximum height, we're going to take -16 times 0.5 squared plus 16 times 0.5 plus 192. So again, we're just typing all of this into our calculator. You should, in your calculator, get a height of 196 feet. So H equals 196 feet. Questions on this one? So keeping with the same equation, we still have that diver jumping off the diving board. Part D wants to know how long will it take for the diver to reach the water. So we have to figure out what does it mean, or what is it telling us when it says the diver is reaching the water. So I need to figure out, is that telling us a height or is that telling us a time? Well, seeing how it's asking us how long, it's asking us to find t, which means this has to tell us something about the height. So if somebody hits the water, their height above the ground is going to be 0. So in this case, the problem for part D is telling us to take 0 and plug it in for H. And then it wants you to factor or solve this quadratic any way you know how possible. So take that, see if you can go ahead, factor it. I believe it has a greatest common factor. So I would factor out a -16 first.
Where do you got it at 12?
I took 192 and I factored out the negative 16.
Okay.
192 and I divided it by negative 16.
Okay. Thank you.
Yep. So in this case, I again always use the asterisk method anytime I can. So using the asterisk method, I'm going to put A, which is 1 in the top left, top right, negative 1 in the bottom middle, and 1 times negative 12, which is negative 12 in the top middle. Then I'm on a mission to find two numbers that multiply to give me negative 12 and add to give me negative 1. It's going to be negative 4 and positive 3. So looking at these two sides here, I have two factors, t minus 4, and I have t minus 3. Now I'm going to set all my factors equal to 0, like we talked about last time. Negative 16 will never equal 0. There's no variable there, so there's no possible solution to come out of that. The next factor we have is t minus 4. Set that equal to 0, and we get t equals 4. If I set t plus 3 equal to 0, I'm going to subtract 3 from both sides to get t equals negative 3. We're going to look at those two answers and determine that one of them doesn't make sense in context of the problem. So remember, we were asked to find how long it would take the diver to reach the water. It's not customary to say negative 3 seconds. Our answer here would just be 4 seconds. Questions on this one? All right. Oops. Next question, we have the Empire State Building is 1,250 feet tall. If an object is thrown upward from the top of the building with an initial velocity of 38 feet per second, its height s seconds after it's thrown is given by this function. We want to know how long would it take the ball to hit the ground. All right, so in this case, we're being asked how long would it take for the ball to hit the ground? So again, this is another problem like the last one where they're telling us if the object is hitting the ground, the height is going to be 0. So we're going to take this function notation out and we're going to replace it with 0. So now we have this equation here. This one has much larger numbers in it. You can't factor out that -16 like we did before. When this happens, I highly suggest that you just jump to the quadratic formula. So for those of you who have forgotten the quadratic formula, I'm going to write it over here to the side. So this should have been something you use in Algebra 1 and Algebra 2 as well. So we're going to take the equation that we just wrote and we're going to plug it into the quadratic formula. All right, so in our quadratic formula, we want -b. In this case, b is 38. If it helps you to label A, B, and C, by all means, take the time to do that. So we have -38 plus or minus the square root of b squared minus 4 times A times C. All divided by 2 times A. So now we have our quadratic formula all filled out. We need to work through simplifying the quadratic formula. My suggestion is always to students, take this part that I just highlighted, just that portion, and type that into your calculator. Do not include the square root. So just type in parentheses 38 squared minus 4, and then in parentheses -16, and then in parentheses again 1,250. So when I type that in my calculator, I'm getting 81,444. For the denominator, I'm gonna go ahead and multiply 2 times negative 16 to get negative 32. Once again, we're gonna take out our calculators to help us find our solutions. So to do this, we're gonna have 2 problems. We're gonna have negative 38 plus the square root of 81,444, all divided by negative 32. We're also going to have negative 38 minus the square root of 81,444, all divided by negative 32. The reason we have 2 of these is because of that plus or minus sign right here. So we're splitting that plus or minus sign up into 2 problems. Now in your calculator, we're gonna have to be kind of tricky when we type this in there. I would suggest that you type this top portion right here into your calculator first. Then I would hit equals and then divided by the negative 32 on the bottom. So take a moment, see if you can take negative 38 plus the square root of 81,444. Hit equals, it's going to give you a very long decimal. Don't clear it, don't do anything with it. Just go ahead and click the division button and it'll bring up answer or some sort to say that it has that long number in there for you, and then divided by negative 32. So for this first one, I'm getting a values of negative 7.7307. And automatically looking at that, I know that this answer is going to be extraneous because we're talking about time, and time is a negative. So then I'm going to go to my other option. I'm going to take negative 38 minus the square root of 81,444. I'm going to hit equals after I do that top piece. And then I'm going to type divided by negative 32. And that gives me a value of 10.1057. That is positive, so I'm going to label it seconds for my answer. So this tells us that this object that was thrown off the Empire State Building would hit the ground after 10.1057 seconds.
When you take the difference when you use the square rule.
So we're subtracting that square root.
Yeah, but for say in what? Well, my language is Spanish, so I a little confused sometimes with the English. So when you read the problem, what part of the problem told you that you need to make it a square rule?
Oh, there wasn't anything in the problem specifically that told me that I had to use the quadratic formula over here that had the square root in it. When I looked at these numbers here in the equation, I could factor out a 2, but I couldn't factor anything else out. So my best way was going to be the quadratic formula. We could have done this process for every single problem. So the quadratic formula will work on all of these problems.
Okay.
This one, we had used the quadratic formula because the numbers were so large, and then our answers wouldn't have factored anyway.
Okay, I understand. Thank you.
All right, last one. The engine torque Y in foot-pounds of one model car is given by this equation. where X is the speed of the engine in thousands of revolutions per minute. We're being asked to find the engine speed. The engine speed is just X. So this is just telling us to find X. That'll give you the maximum torque, where they tell you the torque is Y. So we're being asked to find X that gives you the maximum Y value. That just means take X equals negative B divided by 2A. So see if you can do that, and then to find your maximum torque for that second follow-up question there, you're going to take the value that you get for the first part and plug it in. So for the first part, we're asked to find that engine speed. I took negative B divided by 2A. That's negative 23.2 divided by 2 times negative 3.75. I went ahead and simplified that. I got an answer of 3.093 repeating. Since that is X, I technically should label it thousands of revolutions per minute. Because that's what X represents. So that would be my answer for the first part. For the second part, I would take the time that, or not the time, the number of thousands of revolutions per minute, and I would plug that back in for X in order to find Y, the engine torque. So go back to the original equation, you have Y equals negative 3.75. Instead of plugging in X, we're going to plug in that value that we just found. Square it plus 23.2 times 3.093 repeating plus 38.8. So we might have slightly different answers for this one, depending on whether you kept that entire value in your calculator and reused it over, or if you rounded. So I kept the entire value of 3.0933333 in my calculator. And I got a y value. I'm gonna say y is approximately, those little squiggle lines right there mean approximately, because I've done some rounding here, 74.6827, and that's going to be foot-pounds. So the maximum torque would be 74.6827 foot-pounds.